Related rates question, rates of change. This time it involves an angle. So a 5-meter ladder that is leaning against a wall starts slipping down at a constant rate of 2 meters per second. At what rate is the angle theta between the ladder and the ground changing when the base of the ladder is 3 meters from the wall? So we need to draw a diagram. So we have a wall. We're going to call this y. And then we have the ground, which is x. And we have a ladder. So here's our ladder. And we're looking to find this angle theta. So we have a 5-meter ladder. So the length of our ladder is 5 meters. Then it says that the ladder is slipping at a constant rate of 2 meters per second. So the ladder, this is minus 2 meters per second. And we need to find the rate of change of the angle, which is between the ladder and the ground, when the base of the ladder is 3 meters. So x is going to be 3 meters. So let's write down what we know. So we have dy by dt. So y in terms of in the rate of change of y in relation to t is going to be minus 2 meters per second because it is decreasing. And we also have x is 3 meters. So we have an angle. We have theta. So this is going to be, what do we know? Well, we have the adjacent. So we know the adjacent. And we know our hypotenuse. So this is going to be the cosine of theta is going to be x divided by L. Now L is 5, so I'm going to replace L with 5. So we're going to write down cosine theta is x over 5, and we need to differentiate. So we're going to have negative sine of theta. This is going to be the rate of change of the angle. And we have a fifth multiplied by dx dt. So we can substitute in what we know. So we know that dy dt is negative 2. So we have minus sine of theta, and we have a fifth multiplied by negative 2. So if we rearrange this, so we've got d theta dt is going to be negative 2/5. And our angle, so we have sine. So sine of theta is going to be, so on our triangle, if we work out our missing side, we could use Pythagoras, or we may know that a special triangle is a 3, 4, 5 triangle. So that means y is going to be 4. So sine is going to be negative 4/5 multiplied by the angle here. So we're going to multiply both sides by the opposite. So if we multiply this by negative 5/4, and we multiply this side by negative 5/4, so this side, this will cancel. And then we'll have 10 divided by 20. So our rate and change of our angle is going to be 0.5 or a half. So this is going to be in radians per second.